Okay, welcome to week 6 of Programming Fundamentals with C Sharp. My name is Jim Kaufman, and I work for Rankin Technical College, and I'm the instructor for this course. Kind of wanted to go over week 1 in review. So we worked on a couple written tests, and we kind of worked through those in class for chapters 2 and 3. And then also we had chapter 2 and 3 labs that we also worked through those in the class, all but I think the fourth lab. So you kind of did that one on your own. I did do a quick glance at the GitHub repositories. Looks like pretty much everybody was able to get their code committed, which is great. So the way grading will work here is, usually sometimes I try to grade a little earlier. It didn't happen this week, but usually, it's not until after everybody checks everything in. Usually it's like on a Monday. After the class is over, I'll start grading. So, between, it's obviously we had a holiday this week, so it's Tuesday already. But, generally your work will be done on Sunday at midnight. Then usually like Monday, Tuesday, I'm grading. So for today's Tuesday. Hopefully I'll have all your grades completed before the end of the night tonight. So I'll be doing that. I just did want to kind of just review a few things on the. Let me just bring up the syllabus here. So if you don't get your labs done, they can be submitted late. Okay. One thing is written tests cannot be submitted late. So whenever the deadline is for that written test, you need to get that done. So all other coursework can be submitted late. So how that works, basically take 10% off the top, and then it's graded. And I know a lot of people say, "Oh, I can just turn in something late," and that's fine. So some people do, but generally, when people start really falling behind, it just doesn't happen. So that's why even though you can submit something late, it's really beneficial to get as much done on time as possible because once you start falling behind, it'll snowball on you. Um, if you do turn in anything late, please let me know. Um, please communicate that to me. Just shoot me an email saying, "Hey, I'm turning in a late assignment," and just give me a couple little details about it. So this first week, if there was a couple. I didn't go through all of the repositories for all the students, but I've seen a couple where it looks like not everybody might have turned in like the third or fourth lab, and I'm not sure why. One thing is, I know sometimes those documents, especially on Google Drive, their spacing. You really gotta make sure you scroll down and see all the assignments on there. I seen a couple that were a little messed up as far as formatting, so I kind of changed that. But you just have to make sure you scroll down and get all those assignments. Um, yeah. So this first week, if somebody is going to turn in a lab, I'm not going to take any points off this first one. So as long as you get the first week assignments, completed this week, I won't take any points off. But starting next week, if it's not completed, if the labs aren't completed by Sunday, um, then I'm gonna be taking off points for that. The 10% if you turn in something late. Um, just kind of want to review. If especially with the labs, if you don't see it on your GitHub repository, the actual one on the internet, not your local one, but the GitHub repository that's on GitHub. If you don't see your code up there, it's not uploaded. So a couple challenges. A couple students that contacted me this weekend was just not putting their code, and we kind of went through this last week a little bit. People not putting their code in the right directory in their actual local repository. You got to create your projects, and if for some reason you mess that up, you have to copy that. You have to copy that code from the one that was wrong into your repository. Either way, but you want to just really get in a habit of creating your, your assignments in that local repository, right? Um, just getting a habit also of, just checking things in, often, even if it isn't completed, check something in, because especially, I've had people with attendance, have problems with making it, something happens in their life. We all have things that come up in their life. And they were working on code. They didn't check anything in, and then by the time the Sunday came, it was too late. They had some personal stuff they were dealing with, and then they get marked as uh, absent for the week. So it's really easy to avoid that, especially if you're spending time spreading your work out throughout the week and doing a little bit of work here and there. You're going to have much more success, right? And then you can make sure that you get something submitted, so at least you're marked as present for the week. So I did want to go real quick here. I want to go to GitHub Desktop. I know maybe this is a little bit of review, but I just want to go over a couple things real quick, just because I know people did have problems with their directory structure a lot. So here's my GitHub. So basically, if you go up here where it says current repository, you right click and show and explore. This is where your GitHub repository is. So you need to know. This is where you're going to want to make sure that you create your assignments and save your assignments, right? Now, also sometimes, even within Visual Studio, it doesn't always easily show that. And, let me show you something here. So let me go to this. So, and here, you can basically, sometimes people get confused where their project is here as well, right? You're just coding along, you don't see anything. You can always click on this, right? And then go down to Open Folder and File Explorer. So oh, yep, this is where I'm at, right? So mine is a little different. I'm doing things in a couple different areas depending on what I'm doing, so don't get confused. But this is going to go to where it's saving your code, right? That's where that code's associated to. So, okay, I wanted to go through that. So kind of want to go through this course grading a little bit. Also, so the written tests are worth 15%. So don't get too confused with sometimes those other tests are like worth 100. Your lab's worth 100 points and this and that. You just got to really think of all the written tests you take in this course. The whole group of them is going to be 15% of your grade. So it's a lot smaller, right? And pretty much the reason we've done that, myself and some of the other instructors and myself, is because some students were having problems with written tests, and so we kind of try to not make them worth as much. They used to be worth a lot more than 15. So the written tests are worth just 15% of your grade. That doesn't mean they're not important. Really all the grades are important. And I would say, you just really want to make sure you complete your written test by the end of the week. Even if you're not spending as much time on them as you like, just, get something in there. And, for some reason, if you fail one, don't worry about it. A lot of different students, even some of the best students, fail, written tests. So, but, I'm not saying you shouldn't try to do well. Obviously, everything impacts your grade, but, just don't, get too hung up on it. Do your best. And as far as those written tests, we went ahead and this previous week we did that in class. So this next week, starting, this week and going forward, you're going to kind of be doing that on your own. And so I'll provide those study guides. I'll provide those, and then also I provided chapter 4 and 5 for this week. Okay. So you use the study guides, the chapters, and also, use the internet and any resource you have, at your disposal to work on this written test. Okay. And then I also wanted to, just point out that the hands-on test, and I know we're probably like first day or whatever, went through this a little bit. It's hands-on test. This is worth 40% of your grade. So that's a significant amount of your grade. So when, you want to make sure, you know, I keep on saying make sure you do these and do that, everything. But hands-on tests are very important. You really want to, like if you for some reason fell behind and get your lab done, don't do your lab over your hands-on test or something. Okay, make sure you get your hands-on test done. Even a written test. I wouldn't worry about a written test if you need to get your hands-on test done. Okay. But the whole thing is kind of tricky because a written test you can't do a retakes. So, you just got to figure out a plan that works for you. Okay. And I guess that's all I really wanted to discuss in there. As far as books are concerned, I'm still waiting to hear back. We did on that questionnaire asked about a book. I did contact the bookstore to send a number of those books out to the Wentzville, and then also I have a student that lives out in Columbia, so trying to get that, and I sent an email about getting that down to Ashland, which is close to there. So still waiting. So don't go to Wentzville, don't go to Ashland or Wentzville to pick up your book. Wait till I let you know about that. So as far as the assignments for this week, so basically the first one is the hands-on test, all right, and this is due Thursday. This is due Thursday by 7 a.m. And then we have 2 written tests, and then we also have labs. Okay. And you've got your email from this morning that has the book chapters. And the reason I did is control key click, because sometimes you click this and especially from a Word document, if you're ever working a Word, you really need to hit the control key and click it. There's a little confusion about that this weekend as well. But here's some resources for these are resources for the written test and so forth. Okay. So what we'll be doing this week is, first I'm going to go over really this hands-on test now, okay? And then not going to be really going over the written test, and we'll be going over some areas that concepts that will be helpful for the written test, right? But I'm not going to be going through the written test question by question. The labs. We will kind of go through that lab document, pretty good. I'm not going to be, doing those exact labs, but I will demonstrate some labs that are similar to that, right? I have a couple lined up that we'll do those, we'll do those in class, and they'll be similar to what you'll do on that assignment, right? So I think we'll go ahead and take a look at that hands-on test. So as you can see, actually I cross this out. It says in 2 hours or less. So one of the advantages of being in an online course that you're getting, I'm giving you a little extra time. Obviously if you were in person, you would be sitting down. If today was the hands-on test day, you would be sitting down and at your on the table at the campus, you'd be working on your test, right? And you'd be given a couple hours to do it. So you're going to have plenty of time to do this, and you basically got 48 hours to turn this in. So here's the different exercises, right? There's three different exercises. The first one's pretty basic, and like actually I said this to another student. So basically the labs that you did this previous week, if you can do those, you shouldn't have any problem with this. All right. This is just a basic hello console app. These are all C# console apps. Here you're gonna any 3 real numbers prints an average for those numbers. Okay. And then here you're gonna write a console app that prompts a user for their name, address, city, state, zip code. quantity of t-shirts are ordered at a certain price, right? And then, it kind of gives you, and here's the additional information you need. And here's kind of a screenshot of what it should look like. So this shouldn't be too bad. This is obviously be the hardest of the three, but it shouldn't be too bad. Now, this is something that, if you have some questions about anything on here, I can answer questions, but, I'm, labs, I can help you through them a lot more if you're having problems. The hands-on test, really something you really need to be doing on your own, okay? So that's that. Okay, so then I wanted to bring up, so we talked about the hands-on test, chapter 3 directory. So let's go to that. And if you can follow along, it probably would be best on this. So let me get to where I want to go here. So if you go to this hands-on test, go to your repository hands-on test, you get this chapter 3. Obviously, you can tell I was doing something because you got this little warning there. Now, if you go here to your, there's exercise 1, 2, 3. So this is already, you already got the boilerplate code for the solution, and here's the labs, or the exercises. Go ahead and click on the solution, which is the chapter 03 sln.sln, okay? Double click on that, and that will bring this up in here. Now, I know we already kind of seen this before. We've got these, it's telling you, there's a new way, because previous versions, you could just do basically this, and it would print hello world, but you have to write the code a little differently, right? And I'm sure that you all remember this from last week, but if you basically go to that link and go down here, and you just want to copy this code, right? This will get you started. So this is your little starter template. Copy this code, all right? And then paste this in here. But besides that, also you'll see over here on the solution, I actually should have brought this up first. In the Solution Explorer, you'll see the project is targeted for a version of .NET which is not installed. And that's just because when this got created, this is older. So if you just click on this EX1, you'll see this target framework. If you change that net and change that to an 8 there, and save that. And then the next one, which was exercise 2, also change that to an 8 and save it. Control S to save. And then here's the third one, change that to an 8, save that, and then you can just click that, and that should be, let's make sure that that does in fact take care of that. And it better. Yeah, good. So you don't see that message up there anymore. Besides that, you don't really need to do anything else within these files. These are these project files. You just close them out, right? So then for each one, you can just go ahead and put your template. You open this up, program.cs, there's that template. So for each one, just go ahead and put your template and get started. Should be pretty basic. I mean, you've already done this in the labs, so this shouldn't be a big problem. So that's all you need to really get started on this hands-on test. Basically, you get this done, and then you get Hub Desktop to push it out. You got 2 days to do this. 48 hours, it shouldn't be too bad. Okay. Let's let's see the next thing here. I did want to go ahead. There's an attendance video that I'm kind of required to show you. I know we did that orientation one, but there's actually a separate attendance video. So let's see, it's 8:30 now, and I think this will run about 20 minutes or so. So I'm going to go ahead and show this attendance video. It's shorter than that orientation one, so I'm going to show that, and then after that's completed, we'll go ahead and take a break. Go ahead and take a 15-minute break, and then come back after that. Okay. And then we're going to start getting into Chapter 4 work. Anybody got any questions at this point on anything? Oh, okay. Sorry, I see some stuff in the chat. Yeah. Yeah. So the question is, should they look bare bones or look a little better? These are the console apps. Yeah, they should look a little better. I mean, but with the console apps, console apps are pretty basic. When you start doing win forms, that's when you're really starting to position things, and that's where the aesthetics of how your user interface looks are a lot more important. But just for the console app, make sure your code looks good and your spacing looks good. Just do your best on that. It shouldn't be too bad, because even that other lab where we did the pay raises things, the pay raises, that had that little table and stuff. That was a lot more complicated than what we've got here for this hands-on test. So. See somebody else putting a question in.
That everybody's clear on the expectations. And then finally, attendance is one of the reasons that students fail at Rankin. So we want to make sure that we're doing all we can to get this information to you in meaningful ways that you can understand and absorb and change your behavior if necessary. First, I want to call your attention to the class times. Your seated courses start at a specific time, which means that your instructors are expecting to see you in that space, ready to go at that published time. So first, what we want to have you do is make certain that you know what the start time is for your class. It's the expectation that you arrive to the class prior to the published start time. So if class begins at 6:00 p.m., then the expectation is that you will arrive before 6 p.m. You will arrive, you'll have time to find a parking space, locate the building, locate the classroom, gather your things, and sit down and get comfortable before 6 p.m. and not walking in at 6 p.m., maybe sometimes being a disruption to the course, okay? We want to direct your attention to the course schedule because that's where you'll find the published class start time. And then we also want to refer you here, as shown in this slide, to the course information tab on your course on Inside Rankin, because the specific published start time should be the exact same in both areas. So now we'll get to the attendance expectations. It says all students are expected to attend or attempt all course sessions and remain in the course the entire duration. So if you're in a face-to-face course or a seated course, if you will, you are expected to attend that course every day that it is scheduled or every evening that it is scheduled, whether it's Monday through Friday, Monday through Thursday, Monday, Wednesday, Friday, or Tuesday, Thursday, or even a couple of nights in the evening. You are expected to attend all the scheduled course sessions and stay for the entire duration of the class. In the online environment, or what we also call the internship courses, the same applies. you're expected to engage in the course throughout the week by submitting work. There'll be more on this in the next couple of slides. As for your seated courses, all students are expected to attend all course sessions and remain in the course the entire duration. Again, here, your face-to-face or your seated courses, your attendance is recorded as present, tardy, or absent. In the case of being present, it means being in class on time, returning from break on time, remaining for the entire duration of the class. If you do that, then your attendance will be recorded as present. A tardy designation means missing up to 10 minutes of the course, late arrival, or a late or delayed return from break, or an early departure. If any of those is the situation in your case, then you will be marked as tardy. And then finally, an absence is regarded as missing 11 minutes or more of the course, whether you're late or you return late from break, or you leave early from class, or you never show up to the course session. And I will just say this about absenteeism. If you find that you're going to arrive and you'll be marked tardy, or if you find that you're going to arrive and you'll be marked absent, I would still encourage you to attend the class, because that way you don't miss the material. You can still prepare for the performance exams. You can still get the knowledge and the information to complete the homework and other assignments. So again, if you're marked absent, that means you've missed 11 minutes or more of your course. And it would be a good idea, though, to still attend if at all possible. Now for the online or the internship courses. So this means you are actively participating once during the week. Attendance is recorded the following Monday. So if I have an online class or an internship course, my class is available to me Monday through Sunday, the entire week. The materials are open and available to me. I can do the work, I can submit the work, I can complete the work when it's convenient for me, as long as I meet the deadlines, the published deadlines that have been established by the instructor. You can find that information in the syllabus, okay? So once I submit that work during the week by the deadline, I will be marked present the following Monday, okay? So if I have 4 homework assignments and I turn in 1 of those assignments, but I don't turn in the other 3, for that week I will be marked present because I have submitted an academic assignment, submitted a quiz or an exam, I participated in a post or online academic discussion. I have engaged, I have submitted work. If the next week I have 2 assignments, but I only submit 1, then again, that following Monday, I will be marked present because I have engaged in the course. In week 3, if I have 4 assignments and I don't do any of those assignments, I miss all the deadlines for that week, then I will be marked absent the following Monday. There is no way to earn a tardy designation in the online class. All right, next, we're going to help you to identify the number of course sessions. First, we're going to have you look at your schedule and identify the begin and end dates of your courses. So if you began classes today, Monday, August 26th, and your course runs the entire duration of the semester, which means it ends December 19th, you're in about 80 days of course sessions, okay? So using the calendar, which is found on the Home tab on Inside Rankin, count the number of dates you are expected to attend each class. If you only attend class on Monday, Wednesday, Friday, for example, only count the Mondays, Wednesdays, and Fridays until you reach the date that the course ends. And just as a precaution, do not count the holidays. You're not expected to attend class on the holidays, even in the online environment. Now that you've identified the total number of course sessions on the semester calendar, You're going to use the table above to identify the total number of course sessions and then find the allowable number of absences. This table can be found on page 27 of that student handbook. On this table, column 1 shows the minimum number of course sessions, the middle column shows the maximum number of course sessions, and then that final column shows the allowable number of absences. If, for example, you are in a course which meets a total of 64 times, you would then locate the 64 on that table. The number 64 falls between the minimum number of 57 course sessions and the maximum number of 68 course sessions, which means that the allowable number of absences for a course meeting 64 times in the semester is 5. There are 5 allowable absences for a course which meets 64 times. After the 5th absence, the student is separated from the course automatically. Your instructor is required to submit a course dismissal form. When that course dismissal form is submitted, within 24 hours of that submission, your name will not be on the roster any longer. The registrar's office will pull you from that course. Just to make sure we understand, we'll do the same thing for students attending an evening school course here in St. Louis. So once you determine the number of course sessions for the entire semester, you look at this table found on page 27 and you identify the allowable number of absences based upon the total number of course sessions. So if you are attending a class on Monday, Wednesday evening, you have 32 course sessions for the entire semester. You would locate the number 32 on this table to determine then that you're allowed 3 absences for the entire semester. At the 4th absence, you will automatically be dropped from the course. The registrar's office will automatically separate you from that course, and you as a student will be required to submit a notice of appeal form if you choose to. Appealing a dismissal from your course. It says students may choose to appeal dismissal from a course. To appeal, submit the appeal form by using the link below, which is found on the Student Services tab at Inside Rankin, or you may submit an appeal by scanning the QR code included at the left side of your screen. The form has 3 open fields available for uploading evidence to support that appeal. This evidence would be the reasons that you missed class, the reasons that you could not attend class at all, or the reasons that you had to leave early, or the reasons that you showed up late, okay? One thing I want to point out, and I really want to stress, which is what makes this different from the procedure in the past, students are not allowed to attend class while an appeal is pending. If you're separated from the course, that means you can no longer access your course material, your homework, your tests, and your quizzes. That puts you perhaps further behind. So I want to make it clear that number 1, when you exceed the allowable number of absences, your instructor is required to submit that course dismissal. You have 2 days, 2 school days to submit that appeal. 2 school days. If you fail to submit that appeal within 2 school days of your notice that you've exceeded, you will forfeit your opportunity to appeal that dismissal. Students are notified of the results of their appeal through their Outlook email account. We do not email you at your personal email account. We email you at your Outlook email account. So please monitor that regularly. Approved appeals result in the reversal of that withdrawal from the course. Remember, I told you earlier that the registrar's office automatically withdraws you from the course within 24 hours of the point at which you exceed it. Okay? If your appeal is approved, that reversal will happen and you'll be notified. If that appeal is denied, it is forwarded to the Academic and Disciplinary Review Board for an additional review. The Office of Education will contact the student to schedule a meeting to review that appeal. An approved appeal will result in you going back into the class, being able to earn a final grade. A denied appeal means that there is no opportunity to return to the course. You'll have to take the course again in a future semester perhaps, and you'll have to pay for the course again. And I would encourage you, if that happens to you, that you should contact your student success counselor to ensure that you're clear about the next steps. When your appeal is granted, you will receive an email which provides instructions for your instructor to adjust your attendance. Absences are not excused. It's just that you are allowed to continue in the course at the maximum allowable absences, which means that you have no more absences. You cannot miss class any further. And now we'll cover attendance and review. Some final points to consider. Failure to appeal dismissal by the published deadline, which is within 2 school days of your notice that you've exceeded the allowable number of absences, may result in a permanent separation from the course. That means it's your responsibility to monitor your attendance, to know the allowable number of absences available to you, and then take the proper steps to appeal dismissal within a timely manner should you be forced to do so. Otherwise, you forfeit your opportunity to get back into that class. Students are not allowed to attend class while an appeal is pending. This is critical. This is the change. This is the part that should cause you really great concern. So you've now exceeded the allowable number of absences. You have an appeal that is pending, but while your appeal is pending, you cannot attend class, which means you cannot access your homework, you cannot access your coursework, you cannot access your performance exam, so on and so forth. In fact, you can still log on to Inside Rankin, but that course is no longer there. That course is no longer available to you. So it's really important that you move in a timely fashion, submit the appeal form, submit the proper documentation so that you can get back into the class as soon as possible. Students are not allowed to appeal a single absence until they violate the attendance policy altogether. Students should hold on to their documentation or their reasons or their evidence for the absenteeism until they submit that appeal. Oftentimes, students will show up to class and they have a doctor's note from the dentist, or they have a note from a therapist, or they have a note from their employer or about some situation. And while we think that's valuable, you should hold on to that documentation because it's not for your instructor to hold on to. You should hold on to that so that in the event that you have to submit an appeal, you had that documentation, you could take a picture of it and you can upload it to those empty fields so the evidence is there, and it will, in some cases, expedite your review. You should make sure that your documentation is valid because we do go out of our way to verify that it's authentic. When submitting images in real time, images meaning your evidence, like a flat tire on the highway or something of that nature, we want to ask you to ensure that your student ID is included in the picture. That way, we're sure to make sense that it's authentic, right? Finally, or almost finally, multiple consecutive absences such as military leave or planned hospitalizations should be communicated in advance. Contact your student success instructor for details. If you know that you're going to miss 2, 3, 4 days of class, consecutive days of class, and you have documentation in advance, you can go on and submit that appeal form, but don't just disappear, because what happens is you will automatically be separated once you exceed, and then the college has to take it a step further and report you as someone who's no longer enrolled. And that has all kinds of implications. Okay. Finally, denied appeals are referred to the Academic and Disciplinary Review Board. I will tell you that repeat appearances before that board are strongly discouraged. You don't want to go before that board at all, especially if you've been there before. Okay? So you don't want to do that. Finally, if you have questions about this policy, we're going to suggest that you ask your instructor. If you still need further information, ask the program chair. And if you need even more information, ask the Dean of Academic Affairs. And as always, I'm going to encourage you to reach out to and keep your student success counselor in the loop. Thank you for your time, and hopefully this information has been very useful. Good night.
So we're going to go through Chapter 4 concepts. And so what I'm going to be doing here, this is a pretty big PowerPoint presentation. I'm not going to go, some of this I'm not going to go through, but I will go through a good portion. But I'm going to flip between this and some other documents, and also the visual source, so we can look at some code as well. Okay. So some of the things we're wanting to accomplish here is given a arithmetic expression and the values for the variables in the expression, be able to evaluate the expression. Use numeric and string data as needed within your application. That means you should be able to do any of the following: declare and initialize variables and constants, code expressions and assignment statements, use the static methods of the math class, generate a random number, cast and convert data from one type to another, use the correct scope for your variables, declare and use enumerations, and work with nullable value types and null coalescing operator. Okay, what's here? Describe the differences, different ways of casting. Okay, and describe the differences between class scope and method scope. Okay. So, Java, C# has many built-in value types, and we've used some already. I think we used an int and maybe a decimal. So we've used a little bit. I think a double. We used a double. So there's different these built-in types, right? And they all have ranges. So you can't, if you try to define a byte. If you define one of your variables as a byte, you can't assign that the value of 256. It will not compile, and in the editor, you'll see a little red squiggly line under it because it will not, it's outside of the range of that. Okay. So a lot of these different built-in types have some that have signed and some unsigned. So here you got a byte that ranges from 0 to 255, whereas here a S byte, which is a signed value, is going to be from negative 128 to 127. Obviously, if you add 128 plus 127, you're going to get 255, right? So this one, the S byte, is going to allow both the negative numbers and positive numbers. One thing I did want to bring up here is, as you notice, it says value from 0. We're always used to counting. We always count, start with, in the decimal system, we always count with 1, right? 1 through 10, the first 10. But, in computers, you start with 0. The first value is basically a 0. And you'll see that in a lot of different things we'll do. Especially when we get to what's called arrays, where an array can hold on to multiple items. Well, your first item in your array is in, you have to, when you're referring to getting something out of an array, you have to refer to it. One way to do it is refer to its location within the array. Well, actually, the first item in that array is at the 0 position. So we'll see that as we go forward. But there's a lot of things within computer science, within different programming language, that starts at it's 0 based. Things start at 0. Okay. So let's talk about a byte. A byte is 8 bits. Okay. So I'm going to go through some things that's not necessary. That's you're not going to necessarily need to know for doing your homework and stuff. But I think it's important to understand some concepts here. Being in a programming program, being in a technology program at the university at Rankin. So, what are bits and bytes? A bit is short for a binary digit. It's the smallest. Let me just make this a little bit bigger. It's the smallest unit of data in a computer. So, all of computers are based on the very beginning of computers when they were designed. They were based on switches. It's either on or off. A bit's always on or it's off. A 0 is off. A 1 is on. Okay. There's only 2 possible states, right? Same as you could say true or false. Okay. And it's the bits are the the building blocks of digital data. You always notice, especially when you go buy a computer or that, what is it? It might not say, well, sometimes you'll see 64-bit, right? When we download things, it'll say 64-bit, 32-bit. So, that it all fits together, right? So a byte is a group of 8 bits, okay? So for example, a single byte, okay, which is bits, can represent up to 256 different values from 0 to 255, like we just seen, right? So it's enough to encode a single character in ASCII2 standard, right? So as far as the standards, like I said, this is not going to be on the test or anything, but it's kind of good to understand that there's different standards for data, right? A lot of, that's really what you're dealing with, right? In programming, you're dealing with data, values, data, right? And there's different standards. Now, the ASCII standard is basically the English standard. And so let me show you a little bit on this. And please don't get too confused and too worried about this. So here's an ASCII table. So let's just say, for instance, whenever you send data, okay, let's say you send the number, you send data from one computer to another computer, right? From one place to another place, right? When you type in numbers and letters, that's not actually what gets sent, right? It gets changed to a different format, okay? And so if you're sending, you can designate what kind of information you're sending, and the receiver of that information can designate what they're expecting too, right? So for an ASCII character, these are all, don't get confused by control characters. We're not going to really talk about them. But here's the decimal values, 0, 1, 2, 3. And so when you're sending data, even though you don't know, when you're sending, if you're saying, hey, I'm using ASCII, and I send a 32, I'm sending a space, okay? If I'm sending a 43, I'm sending a plus. And you also notice there's these numbers. These are binary numbers, okay? We're talking about those bits. Each one of these is a bit, right? These only can be 1 or 0. So here's your 8 bits, right? We're talking, so this is 1 byte of data, all right? And so if you want to look at this first one here, this is at the ones place. So if you had just pretend these are all zeros here. If you had this as a 1 here and all the rest were zeros before that, that would equal the number 1, which is basically up here, right? So you start at 0 is a null character, and then a 1 is basically for the ASCII character set. You know, don't get confused. This is just for their character set. When you designate something with a decimal 1 or with the binary number 1, that's you're referring to this, right? So this goes all the way up until, you know, we're going to start getting to some things that, you know, look a little more common for us. You know, here's an exclamation point, so and so forth. But here, so I'm going to get back to this. So if these were all zeros here, right? This first one is at the 1, right? The second one is a 2. The third one is a 4, then 8, then 16, then 32. So by this being in here at this location, this designates the number 32, which is right there. This is the binary value of this decimal, okay? And like I said, we're for an ASCII type standard. That's what's used here, okay? Please don't get too confused about all this, you know. But you know, just in general, at the very lowest level of a computer, you know, you've got a CPU in your computer. At CPU in your computer, it doesn't know what a Y is. It don't know what the number 6 is. When you write code, it's the same thing. Basically, that code's being turned into, you know, when we look at the C# language, we're seeing a human readable, you know, the programming code we look is human readable. Some of it, you know, we're learning it. Some of it doesn't make sense. We don't know what we're doing, but it is human readable, right? But when you start getting down to every character you send has this kind of a value, right? Then, you know, it becomes very unreadable, right? And when you get down to the very lowest level of your computer, basically that CPU, for that CPU, when you click like the number 4, right? It doesn't know what a 4 is. It's gonna, this is what the computer knows. The computer knows this. It's gonna execute this. It's this is a 4, you know, that's what it uses. It uses binary. It doesn't know what the number 4 is, right? It knows binary. You know, because you got to think also, you know, when we're using a keyboard, these are, you know, more for the English language, right? Well, there's other languages, right? There's Japanese, Chinese, et cetera, right? They use different symbols, different things, and you have to use different character sets. So this character set here, this ASCII character set, this is really just for the English language, right? This is just for English. Okay. So what else did I want to talk about here on this? You know, this is something you can play around with sometime. And basically, what you can do, you put any binary number in here and convert it to a decimal, etc. And you know, this is just more for your knowledge, more than anything else. Okay, but I did want to show you something in. There's a kind of small story I can tell you here. So here, when you use this char, right? This is one of the built-in data types, right? So char is basically you're casting. You know, we're going to cast this character to the integer and the ASCII value, right? So we know our ASCII value, remember, it's like 255 was the highest one, right? So anything past 255 is not part of the ASCII data set, right? Character set. So let me tell you kind of a little story. So, you know, I was working at a government as a contractor to a government agency, and what we did there is we took in data files to do with, list of mortgages, right? List of mortgage, who's on the mortgage, what they owe, all that, right? So all this data, they send us these data files, and these data files had that information. Well, all that information basically was, we didn't have, it didn't have bunch of special characters and stuff like that in there, right? Just, basically, letters, you might have, underscores. They're all ASCII. They were all part of that ASCII data set, right? So what we did, when we got it was all, this was all programmatically done, but we took that data and we would load that into our system. Well, sometimes that would fail. And the reason it would fail is because there was something in that file that wasn't supposed to be there, right? And so what sometimes, and the way, when the way that that process was set up, it really didn't tell you what went. It just blew up, said, nope, it blew up. So what I ended up having to do is I create a little program that read this file in, it read the file in, and it went through the whole file, and it went and got the char value for each thing, for each letter in the whole thing. It's not written like this, okay? This ain't it. But it basically went through the whole file, and it went to see if anything was outside, greater than the 255, because that's the max, right? So here, I'm just going to run this. So here's the ASCII value for 1, and it's going to print this out. Okay, and here's the ASCII value for A. Whenever you do a char, remember you have to use a single tick, a single quote, not a double quote. Okay. Now, like I said, this isn't going to be for the test or anything, but it's kind of important to understand a little bit about this. But this is a character set. Like I said, the English character set, ASCII, and so, like I said, this was a situation where something was blowing up, and I had to figure it out. So what I did was wrote a little program that looped through all of the characters in that document and then printed it out if it was greater than 255. So I'm just going to run this here, and hopefully this is going to run. I did this, okay. So just the ASCII character. So this test. I'm sorry. This is just a method. We haven't done really any methods. It's basically just it's just calling a method, it's passing in your char value, and then it's getting the int value of that char, okay? And so this one is 49. That's if we went and looked at that table, number 1 is 49, A is a 65, a lowercase a is a 97, a pound sign or a hash is 35, right? But then here's this summation or sigma character that I have right here. This is 8721. So that's the character set. That's the value of that, and that's outside of 255. So if you had a file that was supposed to be ASCII characters and you had this in there, that'd be a problem if something was reading it and expecting ASCII characters. I hope that doesn't confuse everybody too much. But, I just kind of want to give you a little story behind that. We were talking about binary data. This is basically what's being sent to your computer. This is how computers send data from one computer to another. And I guess another little sample thing is, when you send a text message, right? That text message has to follow certain rules. And have you ever sent a text message where it was too long? If it's too long, it gets broken up it can be broken up into multiple parts, right? And so when it gets broken up in multiple parts, sometimes the receiver will receive the second one before the first one. Something interesting, right? That's the kind of the rules for sending those messages. When you type all that messages in there, that's not what's really being sent. It's basically the same thing like I'm saying. For a computer on the keyboard, the same thing was with your smartphone, right? You enter that data in your chat application, and basically it is being converted to, it's going down to the lowest level, and it's being, sent over the wire, so to speak. It's being sent to if you're sending it from your chat, that's just a through your phone, it's being sent to a cell tower, right? It's going through a cell tower and it routes to that person, and it's not being sent as those letters. It's actually being sent as more of in a binary state, right? And all those different ones and zeros, right? So that's just more some background. I hope that isn't too confusing. But kind of the important thing to know, just in general, a bit is either on or off. It's a 0 or 1, and a byte is a group of 8 bits, right? And if you've got 8 bits, the biggest number that you can fit into a byte is the decimal number 255, right? So that might mean different things. The decimal numbers mean, we were looking at ASCII standard, but 255 in a different standard could mean a different thing. But we were just looking at that. But also, that is your numeric values too. When you send a numeric value of 10, that's all within that byte there. Okay. So important about bits and bytes. All digital systems, including computers, smartphones, and networking equipment, rely on bits and bytes as their fundamental unit of data. At the lowest level, everything in a computer is represented in bits, whether it's processing instructions, storing data, or transmitting information. Okay. Like I said, for this class, we're writing in programming. It's not important. But at some point in time, you'll have to know more about those different character sets. ASCII is just one of them. You'll have to know more about them as you progress, right? But as of right now, it's not important. But bits and bytes, so data storage and memory, storage devices like hardware drives, your hard drives, your USB flash drives, and memory RAM are measured in bytes. Kilobytes, megabytes, gigabytes, terabytes, right? So understanding that bits and bytes is crucial for everything. Understanding the storage capacity and memory requirements of software applications and files, right? Data transmission and networking, data transmission speeds are often measured in bits per second. Understanding bits and bytes help in interpreting internet speeds, bandwidth requirements, and data transfer rates. So when writing software, developers often need to consider data types and memory usage. And we're going to talk about that a little bit in some terms that are a little more simpler, and because I'm sure I'm being a little confusing here on some of this. But for instance, a char data type uses 1 byte, right? While an int might use 4 bytes. Knowing the size of the data types in bits and bytes help developers optimize memory usage and improves software performance. Security and encryption. Encryption algorithms operate at the level of bits and bytes to secure data. The strength of an encryption algorithm often depends on the number of bits in its key. So 128-bit, 256-bit, the bigger the number, the more secure that encryption is going to be. A deeper understanding of bits and bytes is crucial for implementing and understanding cryptographic security measures. Okay. In fields like data science and machine learning, processing large data sets efficiently is crucial. Understanding how data is stored and manipulated at the bit and byte level allows for more efficient algorithm and data processing techniques. Like I said, don't get too hung up on this right now. I just wanted to kind of give you a little bit of background here. So here, let me kind of give you an example. It kind of makes sense. So, let's say you're creating an application and it's got salary, right? So a salary, do you even want to really, a salary is always going to be positive, right? You're not going to have a negative salary, hopefully, right? So if you had let's say, your first job. So your first job, you probably wouldn't even want to use a short because it's got a negative number, right? It really doesn't make sense. You have to sometimes you have to think about, well, what am I trying to do, and why do I want to use certain types of, certain built-in value types, right? So let's just say that your first job, let's say it's 35,000. Well, you're not going to use a short anyhow, because it's, this goes from negative 3276 to positive 276, right? And obviously, if you add these numbers together, this is the unsigned version, right? And that equals, those two numbers added together, right? So let's say, you got a job, your first job. Let's say your first job, you're making $45,000. Well, this would be a good one to use. But, obviously, in the future, you making more money. So let's say, some years go by, and you're making much more than that. And probably when you design something, you want to think ahead of time. Say, well, I'm going to be making more, so I don't want to use a use short for mine. I want to use something bigger, right? So in this case, let's say you want to use here. This is over 4 billion, right? This is over 4 billion. So this would probably be a better one to use. All right. And like here, you've got a negative number. A salary is probably going to either be 0 or it's going to be a positive number. Do you really want to represent it as an int? People do, and people do this in code all the time. But does it make sense? It's when your final answer is never going to be a negative number, it really doesn't make sense, right? So this int might make a lot of sense to store yours. You're up to almost $4 billion. Now, if for some reason you become a very successful entrepreneur, and you're working for you're making more than $4 billion a year, you're going to need something bigger than that, right? And then you've got this long and long. Well, you get up about here, that's about all you really need. That's quite a big number, right? So just kind of wanted to give you a little background on in that. Just need to learn. Like I said, you go in there and you create a variable. You can play around with this. Create an S byte. You put a variable. If you put something bigger than 127, it's going to complain. If you put a number less than 128, it's going to complain. And that's going to be the case for all of these. Okay, so it's kind of really know your data. So let's go through some situations for that. So here's our built-in value types, and what I got here is when to use, right? So when do you use a byte? You use a byte when you need to store small positive, right? Small positive integer values, and you want to save memory, right? So yeah, let's talk about saving memory real quick. So sometimes you think, well, I can just use the largest one, right? Just use the largest one. I never have to worry about that. But when you designate a variable in your code, right? The compiler, when you compile that, which we don't really compile it. It's all in Visual Source Code. It's kind of all done. It's building that itself. It's we're used the IDE. That stuff's happening behind the scenes, right? It's building that. That's why you've got all those other directories. When you click at the top, the little green thing for that lab or whatever. So when you do that, it's actually building and compiling your code, right? So when you designate, let's say you just use the biggest numbers for everything, it's going to take up a lot more memories, all right? And you know what it's like sometimes. I'm sure we all experience, like, you have multiple things running on your computer at one time. You have Word, this, that, right? You have all these different applications. It really starts bogging, slowing things down, right? And then if you're building a complex desktop application, you're just adding to that, and you've got that running plus other things. And so when you do that stuff, it actually uses more resources, right? Both from memory and from running perspective, right? So you kind of really want to, find something that makes sense for the data you're using. Okay. Okay. It's also commonly used for binary data manipulation, like reading and writing byte streams. Okay. Well, That's when you're reading in files. Reading in files and stuff. This is this is what I was this is what I used when I was telling you about that example. I used the byte stream, read in all the data. It's beyond what we're doing right now. But basically read all that data in, and that's what I did. I read it in, and it would read it all line by character, and it found something that was outside that ASCII character set, and then I end up sending that file back to the sender saying, hey, this is what's wrong with your file. Please correct it and resubmit it, right? So that's a byte. When to use an S byte is when you need to store small integer values that can be both positive and negative, right? So like we were talking about, if you always know that you're going to have a positive number, you don't want to use the signed one, right? The S one. It starts with an S, right? Same thing with a short. If you're never going to, this is something that's never going to be negative, then you don't want to do that. So positive numbers, okay. Int is the most commonly used integer, okay. For general purpose programming, used when you need to store a range of integer values without excessive memory usage, okay. You'll see a lot of people using ints, and I'm not saying there's anything wrong with you using an int, even if it's going to be a positive number, but I'm just kind of optimize, from an optimization type standpoint, it doesn't really make sense, but not that it's a big deal, okay. And long, we start talking about really big numbers here. Obviously, we've seen a double, right? We used a double before, and double's quite big, right? It gives you a lot of floating point, a lot of numbers after that decimal point, right? Now decimal, decimal's an important one because it's you use a decimal for financial and monetary calculations. Where precision is critical and the rounding errors must be minimized. So some of these others, maybe some other time I'll show you where, sometimes you try to use something like a double in that for a monetary things. When it gets rounded, depending on your numbers, you may use double for your monetary, your financial stuff. And might not have a problem. Then all of a sudden something didn't work because it's just the certain numbers that got added up, and the way it rounds it causes an issue. So that's why for financial and monetary calculations, you really want to use a decimal. Okay. So keep that in mind for your labs. If that's a numeric, if it's going to be a dollars, you're putting something in dollars. You really want to use a decimal. Okay. Char represents a 16-bit Unicode character. Okay. And then basically a Boolean. A Boolean's either true or false, right? So that's that. Okay. I'm just looking real quick. All right. And this PowerPoint presentations, this isn't in your, these different PowerPoint presentations. If you want to refer to these, they're in your repository, your local repository. They're in there. Okay. So how to declare and initialize a variable. Okay. I know we've already had to do this a little bit, right? But this is kind of the chapter when this kind of gets discussed a little more. So basically, you've got a type. What's your type? Is int. What's your variable name? You're calling this counter, right? So, and then here, what you're doing is you're declaring. This is called declaration, right? You're declaring a variable, all right? But here is where you're initializing it, right? And in this instance, you're doing it on two different lines, but you don't have to. You can do this all on one line. You just do int counter equals 1, right? But sometimes it depends on what you're trying to do, and sometimes you don't even know what the value is, right? It isn't always one that because it could be something that's generated, right? So you don't always have to initialize it. So A variable stores a value that can change as the program executes. Um, as far as these naming conventions, these have kind of changed a little bit throughout the years, but we'll just go ahead and stick with this. You know, and I think this is a little bit, if you read the documentation for the C# programming language in Microsoft, it kind of suggests a few different things depending on if it's a local variable within a method and stuff like that. But we'll discuss that later. But so basically, start your names of your variables with a lowercase letter and capitalize the first letter of each word after the first word. This is known as camel case notation, right? Camel notation. And it's kind of showing you here variable name, that's lowercase, that's uppercase. Try to use meaningful names that are easy to remember. I know, we all, I know I have, and, I've seen a lot of code where people use X and Y and A and B and C, but generally it's not a good idea in most cases to do that. You kind of want to make it more meaningful so kind of somebody else who's reading your code understands what it means. So how to declare initialize a variable. So just the basics here for a float, you want to put an F at the end of it. If you're ever creating a float, you want to put an F at the end of it to designate it's that. Also in decimal, you want to put an M. M, lowercase or uppercase, it doesn't matter, but that's how do you designate that that's an actual decimal. Because if you don't include this, it'll actually save this as just the way the programming language works, it'll actually save that as a double. So you always have to put either a lowercase m or an uppercase m, okay? Here's an integer. Now here's one that's, this is a nice feature that available in later versions of software is using these underscores. So instead of running it all together like that, right? So how much is this? It's a lot easier to tell. This is 1,734,000, right? So you can use these underscores for big numbers. That's very helpful, right? This is called scientific notation, and in this case, it's just assigning a variable of the amount of stars, and so it's very, it's probably almost infinite, but it's stating a certain amount, right? But this can be, I don't know what the value of this actually is, but it's quite a large number to say, right? So, it's just showing you this is called scientific notation, okay? Remember, a char is always within a single quote, and a Boolean value is always going to be true or false. Okay. You can define multiple variables on one line just by using a comma to separate them. It kind of just all depends on, sometimes if you don't have a lot, you probably don't want to do this when you have a whole bunch of variables because it's kind of messy. Almost sometimes, it's more about readability than anything. What's more readable, and when you're programming, probably the most important thing, even if you're, like we're saying, to call those variables start with a lowercase, and then do the camel case. If you do something wrong, it's best to do something. And I don't want to say it's wrong. It's just that's naming conventions that suggest that people do things differently, right? But basically, it's probably best to get in a habit of at least being consistent. It's better to be, if you're going to name something one way or another, it's better just to be consistent than doing it one way and then, a couple lines later, you're doing it a different way. You just want to be consistency is very important, right? How to declare initialize a constant. We've done this already. I think we did a constant for our kilometers, right? Our kilometers for our lab assignment. So, and this is actually what they suggest for a constant name. A lot of times in programming, and I've always, and I've seen a lot of code that a lot of people just used all uppercase and like did underscores on the name to kind of designate that as a constant. And I think maybe the biggest reason for that is because years ago they didn't have something that designated something as a constant like this. It says, hey, this is a constant. So because sometimes you might set something to a variable and change it later. Like if it's not a constant, right? You can't do that with a constant. But you can just create any variable. You might set it to a value, but later on you're going to end up changing that value, right? You're just setting it to a default value now, all right? And so when when you're looking at code, especially years ago, how would you tell by looking at is this something that might change or not change? And so we kind of always did that with using uppercase letters and underscores for constants, right? But obviously here, when you've got something like a const, it's obvious you've got a constant here, right? So their suggestion is to do this, which is called Pascal notation, right? Pascal is actually a programming language, quite an old programming language, but that was their basic notation. So it's you capitalize the first letter of each word, each word, right? You start with a capital letter, and each word is going to have a capital letter, right? Just here's some examples of constants. So they're using the Pascal. So probably best to go ahead and use that. I know some of this, like, and actually that assignment, I didn't write that stuff, but I probably would have done it pretty much the same as they did, because just kind of out of habit. But, basically, this is probably more of the appropriate way to do that. So you probably should really stick with this. And this would be I think the standards here for Microsoft. I don't want to say standards, but the suggested naming conventions, right? And it's always important to use meaningful names as well, right? I know we all already went through, a little bit of this a while. I think was it day 2 or day 3? We went through some of this, but it's worth going through again. It takes a while to, especially modulus. Some people get confused with modulus, but modulus is very very useful. But we got basically addition, subtraction, multiplication, division, and you have the modulus, which modulus basically returns the remainder, right? And so how modulus can be used a lot, and actually in our labs here on the chicken egg assignment, that's one where modulus will be helpful in that, and but a modulus is used a lot, especially for like UIs as well. So like let's just say you had multiple data rows on your application, your GUI, and you had multiple data rows of data. Well, maybe you want to do you want every other one to be a different color, right? So you can actually use modulus by using modulus, you can tell if it's an odd or an even number. And if it's an odd number, you want this color. If it's an even number, you want that color, right? When you're looping through, multiple rows of data, modulus is used a lot for GUIs and stuff like that. But it has a lot of other purposes in programming as well. And we'll go into that more in the future. And like I said, this will be very useful in your the chicken egg lab assignment. Yeah. Negative sign changes a positive to a negative. Yeah. Well, yeah, putting, most of the time you're not doing that. Yeah. Negative sign. Well, you can actually put the minus just like you would in basic math before a number, and it's going to make it negative. And then when you do two pluses together, always that's incrementing, right? So it adds one. So if you've got here you got X, it's the same as, so let's say you got X. If you go X plus plus, basically x plus plus is the same thing as saying x equals x plus 1, right? And so if you do, every time you do x plus plus, you're adding, you're taking the value of x and you're setting that to the value of x plus 1. So you take x plus 1, save that in x, okay? And that's what basically x plus plus. And in this case, you're doing decrement. You're taking x and you're subtracting 1 from it, and then you're putting in the value of x, right? And I think here's some examples. Yes. I think I might have done this myself here. Okay. So here you've got x is 14, y is 8. X plus y, pretty basic there. X minus y is 6. X times y, x divided by y. Okay. And this is x modulus y. So basically this is saying, let's just do it like this just to make it easier. Oh, I didn't mean to do that like that. Let's put that in here. I don't know why I did it like that. Help if I... All right. So for modulus, we'll just do a quick here. We're going to go into that more later, but so 8 goes into 14 one time, right? 8 goes into 14 one time. What's left over? 6, right? Here you've got a negative y, negative 8, and then you're going to add 14. So basically, I think that's why I put this here. So here's your negative 8, and you go 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So I don't know why that says that down there. That's why. Oh, no. Yeah, it was 6. I'm sorry. And this is decrement. So you're taking 8 and you're decrementing it by 1. So the value is 7. Here you've got x. You're incrementing x by 1, and so it was 14 and now it's 15. And this is going to take about, so basically there's a pre and post increment. This is called pre-increment. You have pre-increment when it's before your variable. You'll have post if it's, because you can do it either way. We'll talk about how that can kind of, I think that's actually coming up here. Here's some arithmetic expressions that use decimals. Like I said, always make sure with decimal you have a lowercase m or uppercase m for decimal. And here, for a decimal, you're always going to have, whenever you have decimal places, your answer is going to have decimal places. Well, now there is ways to, go ahead and format that so how many decimal places you want, and we'll learn how to do that. Okay. I don't see anything too different here. All right. So, and I know I already brought this up before. So, one thing you got to be careful about is assignment operators and comparison operators. So sometimes when you're doing an assignment, you're basically taking a value and assigning that to a variable, right? Use one equal sign. When you're testing, you want to say, is A equal to B? That's when you use two equal signs. That's something you always got to, I know, and I think I mentioned this before, and I know I've done that wrong. It's you're doing something, and all of a sudden, instead of checking if you're comparing to something, you end up assigning something by mistake because you didn't use two equal signs for comparison whereas, you know, one equal sign is for assignment, right? So here's your basic assignment operator. This basically takes so if you got an A on this side and you got an, you know, you know, you basically take an A, whatever you know. So maybe you got A already defined as a 5 up top, and then you basically what you're doing is you're adding 6 to A. So if you had 5 up top, you're adding 6 to A, and now it's 11, right? So and here's subtraction, the same thing, and multiplication. These are kind of just shortcuts instead of, you know, saying x equals x plus 1, right? You can just do x plus equals 1, and it's just going to add to it, right? Just kind of more of a little bit of a shortcut. Okay. Syntax for a simple assignment. X equals 7, new counter equals counter. Yeah. So you're just reassigning a variable to one variable to another variable. Just showing some different options there. Okay. Yeah. So like I was just saying, instead of doing it like this is one way to do it, and nothing wrong with this. The other way to do it is like this. And it's basically going to take, you know, it's going to say, give me the value, you know, take this, add this to this, and then set that to that. Okay. So it's basically, you know, this is the same thing as saying, you know, my total equals the total plus this, right? Same thing here. Total equals total plus this. So, and that's always the case when you're adding numbers to something, right? So that's that. Okay. Adding, well, not necessarily adding, subtracting, multiplying, or whatever. But so the order of precedence for arithmetic operations. So you you start. You're always going to kind of look at left to right, but first you got to look: are you incrementing or decrementing anything within a statement? So if there's a increment or decrement, you do that first, okay? And then after that, is there a positive or negative number? I mean, that's just, I guess, the order of how it looks at it. It looks at a negative number. Then from there, you're going to go ahead and do multiplication, division, and modulus, basically from left to right, right? And then you're going to do addition and subtraction after that, right? And it didn't really mention parentheses. I guess it will here in a little bit. But, you know, if you got a parentheses, you do what's in the parentheses. You're going to do what's in parentheses first, right? Before you do other things, right? And we'll see that down here. So here, you got a decimal. You're setting this to 0.2, which is 20%. 0.2 is 20%, right? This is decimal to a value of 100. So yeah, so you're taking price. So you're going to do the price times 1, and then you're going to subtract the discount, right? You're going to do this before you do the subtract, right? You do multiplication and division before addition and subtraction. So here, it's a little different. What you're going to do here, you have to do what's in parentheses. So you're going to do, this takes precedence. Parentheses is going to take precedence. You might know this. I don't know, you know, people's math background. But so here you got parentheses. So you need to evaluate this first before you multiply it. Okay? Prefix and postfix. Yeah. So here, okay, we got A and B both equal to 5. So y, we're setting y is equal to a plus plus, right? So when you do this, you're doing kind of two things here. One, you're changing the value of a here as well, right? You're incrementing you're incrementing a by 1. It's already 5, you're incrementing a by 1, which is 6, right? Which is 6. And then you're also setting y equal to that value. Okay? You're setting y equal to that value. So both of them are going to be 6. That kind of makes sense, right? So here, though, you're doing, and this is called, you're doing the pre-increment, right? You're prefixed, right? This is a prefixed. You're incrementing it first. Here's a postfix, which is you're incrementing after, right? So in this case, it's a little different because of just the way how postfix works. Is you're setting the way this will work is going to set z equal to b before this does not get done until after your assignment. A postfix is not going to happen. Is not going to the postfix isn't going to happen until it's finished, okay? And so z is going to equal to b, and then when you're finishing it, it's going to add 1. So in this case, z is going to still be 5, right? And then after you assign the b to z, then you're going to increment it, and so then it's 6. So something to keep in mind here. So whenever you're setting a variable like this, when you prefix it, you're incrementing the variable before you assign it. And when you postfix it, first you assign the variable, b to z, then you're postfixing. So you're doing it after. This is before, and this is after. So let's go ahead and it's about 10:05. Let's go and take a 15-minute break and come back at 10:20. So as far as casting, what casting means basically it's saying, taking one value, taking a value of one type and changing that to another type, right? And sometimes you can be doing it without even realizing it. It depends on, like, if you set a double, like in this case, you set a double to 93. Well, I hate that does that like that. When you set a double to 93, and 93 is actually integer value. It's not really a double. A double would be, you'd have to have a decimal point there, right? Decimal point and some values after making a double. So, and when we're saying implicit, that means casting from something less precise to something more precise. So, kind of like, if you got a small box and a big box, you can put the small box into the big box, right? But putting the big box into the small box you really can't do that, right? And maybe that's not the best kind of description, but you're taking something that's smaller, that less precise, and putting it into something more precise, which is fine. It's when you go the other way around that there's some we're going to look at. That's called explicit casting, right? Implicit casting, as long as the thing you're going to is more precise, you can just do it like this, and it's when we're saying implicit, it's just happening inside, right? It's just happening really without you realizing it. So this is actually doing an implicit cast from an integer to a double, right? This is doing an implicit cast of a char value to a integer value. Because you remember we were kind of looking at that, like the ASCII character set thing, it was 0 to 255 for a char, right? That's 0 to 255, right? Or the ASCII value. So basically it's taking the value of that A, right? And putting that and using that, right? So here we've got an example where we've got a double, and we assign the variables A, assigned it to 95, right? And then we've got a B is 86. These are integers. These two are integers. So we can take a double and add integers to that double, right? We can add integers to that double. We're adding it to something that's more precise, right? And then we divide that by 3. So this right here, even though these are integers, both B and C are integers, this will implicitly cast, okay? And so the value, as you can see, is going to have the decimal places, right? So that's that. So here's an explicit cast, right? So here, what you have to do for an explicit cast is you've got to tell it, and it's kind of like, it's not going to automatically do it on its own. It's probably more from a perspective of kind of most, saying, hey, are you sure you want to do this? Because there's consequences, right? So in this case, you've got this would be considered a double value, right? 93.75. You've got a decimal place. So you've got a double value here. So when you cast this to this int, right, it's going to be 93. You're going to lose precision. You lose precision. And that's why you've got to tell it to do it. You got to say, hey, I want to cast this to an int, because it's going to change this, right? It's almost like a warning to you. Okay, if you want to do this, it's fine. You have to tell me you want to do this. So this is what you're doing. This is truncating this. You're losing this. You're going from you're going from something more precise to something less precise. And whenever you go from something more precise to less precise, that's when you have to do this explicit casting, and that's by putting what you're going to in the parentheses like this, right? So 65 is a integer, and you're converting that to a char, okay? And an integer is bigger number. So you basically look at your, we had all the different built-in types and the numbers. So whenever you see something that's got bigger, that the value of that, the how much it'll hold, the memory size of that is greater, then that's when you've got to do this explicit cast, right? And then here you've got a double of 95, and you've got what? And 2 integers. So you're going to an integer. So whenever you're going from an integer, anytime there's a double, so when you do this line here, right, you can add these numbers together. You can add a double and a to integers, and that's fine. That's not this is not a problem at all. It's just that when you're wanting to assign what's the value of this to an integer, you have to do this explicit cast like that. Okay. Decimal result. B and C, yes. So, yep. Result has decimal places. And B and, yep. So decimals have decimal places. So, B and C are integers. So you have to convert each one of those. Before you do that, you have to cast that to a decimal. So here's 5 static methods of the math class. You've got round, you got the POW, you've got the square root, and you got the min and max, okay? So this is raising, obviously the round is you're basically taking a decimal number, right? And you're rounding this to a certain amount, right? I'm not sure, I don't think that put that right, but that's okay. We'll look at some examples of this later. Well, there'll be some examples here, but yeah. So this is to a power. This is the square root of a number, and this is, you know, sending two numbers in and say, give me the min number or give me the max number, right? So here you've got a shipping weight, you know, it's basically a double number, and then you're rounding it, and then you're putting in an int, right? So whenever you round, you're creating a whole number out of it, and if it's a whole number, then, you know, you can put that into an integer, right? A whole number you can. Here you're rounding order total to do two decimal places. This is just taking the rounded to two decimal places. Here we're taking a radius to the power of 2. Yeah, that's, you know, that's a lot to deal with there. Here's square root, just taking a number, getting the square root of a number. Here you're getting the max of two different numbers, all right? And here you're getting the min of two different numbers. So here's just telling you, you know, showing you you've got a number. So basically you got this double and you want to round this to one place. So it's going to be 93.8. It's going to round it up, right? And round. Oh, so yeah, greater than 5. It's going to round this one down. Here you're rounding up. Here you're rounding down. Midpoint rounding away from zeros. 23.75. I'll have to look at that one. So here's your power, 5. Basically you're doing 5 times 5. So if this was a 3, it'd be 5 times 5 times 5. But in this case, this is just 5 times 5, right? Is 25. Square root. Square root of 20.25 is 4.5. Here's the min and max. So you got two numbers. Which one's the max number? And here, which one's the min number, right? And also there's this idea of a random value, okay? So there's some times you want to get a random value. Maybe, you know, maybe you've got a quiz application that has all these quiz numbers. And so what you want to do is you want to randomly choose which question to show them so that you don't show them the same questions over and over again, right? That's what a lot of different, you know, where they mix up questions and answers or tests, you know, they're using something random. Here's all the questions. Let's randomly choose a question from that list, right? So next returns a random int value that is greater than or equal to 0 and less than the maximum value for the int type. Next max value returns a random int number that is greater than or equal to 0 and less than the specified maximum value, right? So like in a case like I was talking about a quiz or something, you know, you'd have maybe 10 questions, your max value would be 10, right? So you want something that's going to be some random number between you know, between 0 and 10, right? Here you got a min value. Well, here what you want to do probably in that case would be actually this one when we're talking about that quiz. The min value is going to be 1. First question, max value be number 10, right? So return me a question that's, you know, between 1 and 10, right? And this next double returns a double value that is greater than or equal to 0 and less than 1.0. It's the next double in a list. So you have one double, give me the next double. It's going to add one dot. It's going to be equal to that or less than that. Okay. Probably won't have to worry about that too much, but return number, new random. So here we're creating a new random using the math class, using this random class, and we a new random dot next. It's going to be an integer greater than or equal to 0 and less than the max value of an integer, right? So that should be quite large, right? Integers, quite large number there, right? Here you're doing next is an integer greater than or equal to 0 and less than 101, right? So in this case here, like I said, as far as our idea about a quiz, right, or a test where your random numbers starting at 1 up to the maximum being 101. Okay, returning a random number and then associating that with a quiz question. Stimulates the roll of a dice. Dot next 1 7. Yep. Die 2, die 1. Okay. Excuse me. So next, we'll discuss declaring and initializing a string. So, basically, string can have a value, like in this case, message 1, invalid data entry, within the quotes, right? Here you can just have an empty quote, or you can have null. So pretty much 3 different options there, right? So here we're joining strings together. We have a first name and a last name, Bob Smith. And so what we're doing here is we're creating a third name, call it name, could be, full name. So the full name here equals the first name. And then if you want a space between Bob and Smith here, you're going to have to do it like this, right? You have to put a space character. So say first name, and then first name, and then a space, and then the last name, right? How to join a string and a number together. So here you've got a price of 14.95, and then you're taking a price equals, and then this is that interpolation, right? So when you're using this $sign like this, right? No, that's not that case. Sorry. So this is just a string. I apologize. This is just a regular string, whatever you want it to put here, and you're just doing that and then putting the price. And actually, this isn't exactly right. Yeah, I guess it is. Yep. So, yep. So here's your string, and then you're just adding your variable, right? How to append one string to another. Well, first name Bob, last name Smith. We already did that. First name plus that is going to give you the space. We take the name plus the last name. Kind of just showing you how to do it a different way, so to speak. How to append one string to another. So we got first name of Bob, last name of Smith. We're taking the name, first name plus that. Right? And then we're doing this, we're just taking the name. So whatever, at this point, we're saying, take our name. What's our name? It's right here. It's first name and our space, and then add to that the last name, right? We're just taking name and adding that and putting the value back in name, right? And this is a common escape sequences. I think maybe we did this a little bit. I think that we had a couple. I think we did have a place in our code. We maybe had some return characters or something, new characters. This is especially good for like console application. Different. You can do different things. You do it. I think I did it when I did that little car object thing when I had those car objects. So I was printing out lines of thing, and then after each line I had a return character, so it would return to the next line. So these are common escape characters: new line, tab, return, backslash, and quotation. Because sometimes you've got quotations within a quotation. right? You might have a quotation mark within a string where you got a begin quotation, an end quotation. You got a quotation in between there. You have to escape that so the compiler doesn't get confused, so to speak, right? That's really what all this escape sequences are, really. Um, so here we've got, yep. So basically, this is going to print out this, and then this is going to print out this, and then it's going to do a new line character, and then it's going to print out that, and actually it's going to be printing a new line character after. So, and then this here, Joe Smith. Yeah, so this is doing a return. No, this is doing a tab. Joe. Yep. So /tab is going to do a tab, and then you're doing Smith, and you're doing a return character. So Kate will be on the next line, and then you're doing a tab for Lewis, and then you're doing another return character after Lewis. So that's how that works. These are the tabs, and then all the return characters. Okay. So here, yeah. So this is a place where you have to escape this. You know, the things like this. This is a file path. This is a problem with encoding. So you have to make sure that you escape that by using that and that in front of each one of those. So make the compiler happy. And this will be the value, right? This is an escape character. Because basically what it's thinking is when you do this, it's thinking, okay, this is an escape character, because that's what the compiler's thinking right now. This is an escape character. What am I escaping? It's confused. So really, what you're escaping here is you're escaping your forward your slash here, right? Message type exit type x to exit. Mm-hmm. All right. Yeah, I don't think we really need to go through that too much. I don't think we did here. Yeah, string message. Is that here at all? I don't think so. This is one way what you're doing. Yeah, this is a different way to handle your double quotes here. You got two quotes here and two quotes here by using the @ sign. Okay, that escapes that. Common.NET structures, define value types. Kind of went through this a little bit. So you got your byte is 8 bits, right? From 0 to 255 for a byte, right? And then numbers get much larger after that, right? So you got 16-bit, 32-bit, 64-bit, right? Float's a single precision floating point number. A double is a double precision floating point number. A decimal is 96-bit decimal value. A Boolean is either true or false. And a char is a single character, right? Always make sure you use that one, the single quote, right? The little tick, the single quote for a char. You don't use the double quote on that. And then you have strings and an object. Yeah, in C#, a string is an object, right? So we'll learn a lot more about that. So here's some common methods for data conversion. So especially, you can convert, you've got a number coming in or double coming in, and you want to convert that to a string, right? You can use the toString. Right? And the toString is a method that converts the value to its equivalent string representation using the specified format. If the format is omitted, the value isn't formatted. Okay. Parse is a static method that converts the specified string to an equivalent data value. If the string can't be converted, an exception occurs. So yeah, parse. A lot of times you see parse exceptions. You got the wrong kind of data type, it can't do it. It's going to throw an exception. Obviously, there's ways to write code so that you catch those exceptions and you do something. You send a correct message instead of just blowing up. It's always bad just your code just blowing up and you don't know why it blew up. And that's something we will definitely be doing later on, is writing our code where we do exception handling. So if there's something wrong, which is called basically an error, an exception, that we can kind of give a message and that way we know what's going on there, right? Try parse is a static method that converts the specified string to equivalent data value and stores it in the result variable. It returns a true value if the string is converted, otherwise returns a false value. Some of the static methods of the convert class. So it's to decimal, to double, to int32, to char, to bool, and to toString. Right? It's going to convert all of those. So here's an example. Statements that use toString, parse, and try parse, right? So here we've got a sales string that's equal to sales. We're taking the sales, which is a decimal, right? Sales, which is a decimal, and always remember decimal. You need to have either lowercase or uppercase m. So we take sales and we're doing a toString on that, and we're assigning that to the string called sales string, right? Here we've got we're parsing this a different way. We're taking sales. We're taking sales, which is a decimal, or this just could be a new variable. Don't get hung up on that, okay? So maybe this is a new variable, whatever. But what we're doing is basically we're taking this string that we created, and this string is now this, right? Just that, right? It's not a decimal anymore. It's just the string value, basically in quotes, right? From our perspective. So it's just this sales string, and we're taking that, and we're parsing that. We're parsing that into a decimal. It's kind of confusing because they reuse that, but you're basically taking your sales string, and you're taking that and you parse that using decimal.parse, and you're creating a decimal from your string, right? An implicit call to toString method. Okay. Yeah. Yeah. So yeah, this is basically just saying here you've got a double that you define, and you putting this, you're setting this string equal to this, and this is just going to be doing this is doing an implicit toString method. It's actually under the hood, it's calling toString, but you don't have to worry about it. Okay. These other cases, you've got to pretty much tell them. You got to tell the parser. You got to tell the C# compiler, hey, this is what I want to do here. Here, this is kind of just implicit, just happens on its own. Okay, it's actually automatically calling this toString call. You just don't know what it is. Okay, a try parse method handles invalid data. So try parse is a good thing to use, and because you can say, hey, go try to parse this. Because maybe you don't know what kind of data is coming in. In this case, you've got a string with a $sign, right? Well, a $sign can't be used in a decimal, right? It can't be used, right? So let's see what we got here. Sales at 0. So, yep. So in this case, you've got you're trying to parse something, and if you can't parse it, it's going to return a true or false, a 0 or a 1, right? So conversion statements that use convert class. So you're just basically taking so yeah, this kind of, well, we've got text fields in our, let's see, 2 decimal text subtotal. Yeah. So, yeah, it's basically taking this text, we're used to within WinForms calling things like this, but grabbing the text field and doing a 2 decimal on that to get the subtotal. Because, like a lot of, what we do on a WinForms, when we enter data into those fields are string data by default. Anytime you enter data into those fields, they're going to be strings. They have to be converted, right? So basically what you're doing is you're converting that string to, a decimal here, right? Same thing here. You're converting years to int. Convert to string on subtotal. Okay. I don't see any reason to really go into that anymore. So there are these different formatting codes, and as you can see, capital C or lowercase c for currency, capital P or lowercase p for percent, and then you got N for number, F for float, D for digits, E for exponential, G for general. How to use toString method to format a number. We got a string, mount toString. Yeah. So here you're basically taking, you have a value, which is, and then based on that value, you're doing a toString. So let's, you have maybe amount of decimal, you're doing a toString on it. And by using these numeric codes, you're saying, okay, this is a currency. If you have a P, it's going to be percent, an N for number, an F for float, a D for digit, right, etc. So here you're doing C for currency, right? Here's your percent, right? Here's your number, and here's your float, right? And so you're giving a format, right? You're doing something to format that number a certain way. Just kind of a shortcut, make things easier. I use the format method of a string class to a format number. Okay. Yeah, we'll have to look at that because it probably could be a little bit confusing there. I can understand that. Just a different way to do it. Yeah, we'll just look at that a little bit more later. Code declares and uses variables. Code that declares and uses variables within a class scope. So when you define up top, I remember we did like that car class, but you define your class up to the top, right? Define your class, pretty close to the top, right? And you also have methods. We haven't done much in methods, but we did our on-click event. We've seen the methods where we put code on-click events. Them are methods, right? So a variable that you define up here, right? A variable that you define up here. So here's number of invoices. Within this method, you have access to that, right? You have access to number of invoices, right? And total of invoices in this method. And then down in this method here, this clear totals on click, you have access to that as well. But you don't have access to things that are like whatever when you define a variable here in this method, right? You don't have access to that variable in this method. The scope of this variable is within here, within this method. The scope of that variable, discount percent, is within there, right? The scope of these variables are at the class scope, right? It's at the very class scope. So these can be accessed by your different methods within your class. But anything that's defined within a method itself has method scope, and you can't access them. You can there's ways to pass them from one method to another method, but if anything that's not passed and it's just defined in one method, you can't access that from a different method. Okay. So the scope of a variable determines what code can access it. If you try to refer to a variable outside of its scope, it will cause a build error. The scope of a variable is determined by where you declare. If you declare a variable within a method, it has method scope. If you declare a variable within a class, but not within a method, it has class scope. A variable and a method scope, a variable with method scope can only be referenced by statements within that method. What we were just discussing. A variable with a class scope can be referred to by all of the methods in the class, right? The lifetime of a variable is the period of time that it's available for use. A variable with a method scope is only available while that method is executing. A variable with the class scope is available while the class is instantiated, right? You remember we already talked about instantiating a class, right, before? So when you instantiate a class, as long as that class is still, so to speak, in memory, as long as that's available in memory, the variable within that class is available, right? Now a method, once you complete that method and you leave that, once that code's executed that method, you leave that method, that variable is no longer available. Which obviously we showed how the only way really to pass it from one method to another is we could pass it, but basically the variable only lasts until that method's completed and it's not available, and it'd have to be recreated next time you call the method. Okay. Let's see here. Some of the constants in the form border style, enumeration. The fixed thick border, typically used for dialog boxes. Okay. So I think for that, I'm just going to show you some code on that. Okay, so I think what we'll do is look at a little bit of code here. Now this is just a little console app, and a lot of it really doesn't make sense because you notice that it's kind of got the squigglies under here because you're not using it after that. It's just kind of an example of these different concepts, but we're not really doing too much with it. Wherever we've got a write method, console write, that's where we're actually doing something with it. So here's a case. Let's just even go to those. So here we go doing a format currency. We've seen before using the C2. We're going to format this currency, right? So if I just go ahead and run this. So formatted currency, 50.75 with the $, right? So the two decimal places, right? And so we're saying currency, right? Formats a currency with 2 decimal places. So that was that one. Enumeration. So yeah, let's look at that variable. So this is just showing you that this is a variable scope, and it's a local variable. It's only available. So we're in the main method here, right? So we're only in the main method here. And so as long as we're in the main method, it's available. Once we're out of the main method, it's not available. Most of the time, you're not going to be doing, a lot of things. Main method's more entry point. You're going to have other methods, but that's okay. So here's an enumeration. And let me show you that days Wednesday. So if we go down here at the bottom, this is how you do enumeration. And basically, enumeration is a group of constants, right? So here you've got a group of days, right? So you've got Sunday through Saturday, right? And this is enumeration. It's called enumeration. This is how you write enumeration. You do enum, the name of it, and then open and close curly braces, and then you put your values in here, separated by a comma. Obviously, the last one you don't have a comma. Only put a comma if you have one to follow that, right? So that's your enumeration for days, right? And then we went back up here. So, here you're saying today is days Wednesday, right? That's not really giving you a lot. We'll go through that and how that could be used. But basically, just enumeration. Just remember it's kind of a group of constants, and this is how you access. You would access within that, right? So let's just say that you could actually have things mapped where the first day of the week is Monday, or Sunday. The second day is Monday, Tuesday, Wednesday, and then But we'll discuss that later. We haven't really talked about nullable much, but this is one way you can actually take a decimal, and you can say instead of giving it a value, you can actually use null, okay, and then you do that by using this question mark, okay, and then you can assign that to null. Yep, that. So here's our final price. Let's just go ahead and run this again. Stop this. Final price 9.99. All right, I don't know if that really helps much, if anything. Calculates 3 raised to the power of 2. So yeah, so kind of quick review when we're doing these different math, to the power. So this is math. So this is basically 3 times 3, 3 2 times. So 3 times 2, 3 times 3, I'm sorry. 3 times 3 is 9. This is the square root of 25, right? Which is 5 times 5 is 25. So this would return 5. This is rounding. So you're taking this number, which you defined as a decimal, and you're rounding this to 2 places, right? So that's that. Here we're doing a random. Generating a random number between 1 and 11, right? All right. So what the controls are referred to in the code. So just kind of a quick little, more of a review, because we've kind of done this a little bit already. So we have a text box, right? And we kind of name the things when we create a name. So we have names and text, right? For our win forms, or our win form maps, we have names, and we have text for each property, right? So you want to make sure the name is always, you don't want spaces in the name, right? The name is something you refer to it. It's kind of, it's basically kind of look at it as a variable, right? That's the name you're giving it. It's kind of like almost in your code, you're creating a variable. You don't put spaces in there. It's what you refer to that box as. I'm referring to, a text box, and in this case, it's has a name of text subtotal. And it's always best to create names that, are helpful in determining what that is, because, you start doing text box 1, text box 2, then you get confused, and especially you decide, well, I'm going to move these things around on my screen. And then before you know it, the text box 1 is the last one, and, things like that, right? So you always want to give it a meaningful name, and it's very beneficial. And I know the book kind of follows the convention of calling, starting your text boxes with TXT, and then the name of your text box, being starting with uppercase, kind of. So this would be called camel case here, using camel case, but starting with a TXT, right? And so that's text box. This is a read only box. It determines the okay. So if you recall, we can select something to be a read-only box. It's just saying this is a read box that displays the discount account. Okay. It's just showing some examples before we get into this text box. And then button, you want to make sure that you call your button BTN first. So camel case with BTN. So this is a calculate. This is an exit button. This is probably something we should do. I know that maybe there's some of the assignments don't. Probably 2 different buttons that we really should add to our forms, and it's up to you. If it doesn't ask for the assignment, that's up to you. But usually it's always good, instead of having to go up and click the X in the top of, on a console app, it's different. You just, you're hitting the enter key while you're in that console. But in a WinForms app, when you bring up a WinForms app, you just got that X up in there in the top right-hand corner. Kind of nice if you have an exit button and you can click to exit it. And another button that's kind of really helpful as well is a reset button. Especially, you've got a lot of, ones where you have multiple fields in there, you're filling out those fields. It's kind of best to be able to just reset that and set everything back to its default values, so then you can re-enter data. Just something to keep in mind. I'll show you how to do that tomorrow. The event handlers. Okay, so this is just giving an example of this invoice total form here, right? Where the first one is editable. Then you got these different read only fields, right? You have a calculate and an exit, basically, and then the exit is the same as kicking the X, right? But it's just kind of nice to have a little exit button. And also you've got those access key, like here you got access key on the X that you can just do your, Alt X to do that. This is just showing on, your event handlers on click for closing. This is all you have to do to close that thing is this dot close. But generally what you really want to do a lot of times on that is you don't want to just do this dot close. That will do it, right? It'll close it. But a lot of times, it's kind of good practice, I guess, that's where you would have some logic saying, are you sure you want to close this? Because sometimes things you're doing could be, a lot of stuff we're doing, we're not really saving data, but, in the real world, when you've got real desktop apps, a lot of times you're changing data and, basically you have a save button and maybe you don't click the save button, you hit exit. It's going to say, hey, you've got unsaved data. Would you like to save this before exiting? Right. So that's always a good logic to have in there. Okay. And this is just showing an enhanced form. Okay. So there's your clear totals, clear totals or resets. That's always a nice thing to have. I don't know. This is something we'd be better off just going through ourselves. Okay. So I'm not going to go through any more of that. So let's see, it's 11:06. How about we do this? How about we'll go ahead and call it a day? I'm sure that if you're actually listening to me here, you're probably exhausted from all of this. So let's just go ahead and call it a day, and give you some time, the rest of the class time, to work on your hands-on test. Tomorrow we will go ahead and work on I'll go through some of the the chapter 4 labs. I'll give you, I'll do some assignments that are very similar. You know, I'm not going to do the labs like we did the first week, but we'll go through some other code, some other applications that are very similar, some other desktop apps, and very similar. So you just kind of can use some of those concepts in the lab work that you need to do. And then we'll go over chapter 5 as well. And chapter 5 is not as grueling as this chapter 4 stuff here, so it'll be a lot easier. So anybody have any questions at this point? Oh, I see something in the chat. Okay. So any other questions about anything? You know, and I know it's going to take a while to learn all these things, and you know, it's overwhelming. You know, I can understand that. You know, you need to learn what you need to learn, you know, to get your assignments done for the most part, and the written test, obviously. So yeah, go ahead and work on your hands-on test. That shouldn't be too bad. You know, like I said, if you completed the labs last week, you know, the hands-on test should not be a problem. You know, make sure you change your .NET. I don't know if you followed along when I did that at the beginning of the class, but go ahead and change that to .NET 8, and that should take care of that. So besides that, I'll go ahead and let you go. Have a great day, and I will see you tomorrow morning.